Hello, this is Rick Harnish. I'm the Executive Director of the High Speed Rail Alliance. Thank you very much for joining us today. We are a nonprofit advocacy organization working to get fast, frequent, and dependable and affordable trains linking cities and towns and small towns across the nation in an integrated network. I want to start with an exciting picture for me of a high-speed Talgo train on the Madrid to Seville line. Our organization started in 1993 with a very simple premise. If high-speed trains can link Madrid and Seville, which is the distance of Chicago to St. Louis or Chicago to Detroit, in 2 hours and 20 minutes, we can do it here. And that was the year that that high-speed line opened, basically the third high-speed line in Europe. It's slow by today's standards. If you were to build it today, it'd be in the 90 minutes to 2 hour range. But this was a picture I took at the end of the celebration of 25 years of high-speed rail in Spain. The conference was held in Ciudad Real, which in terms of Illinois is basically the city of Champaign, where the University of Illinois is. A third of the attendees actually spent the night at hotels in Madrid and took the train in every day. And then for one of the days, we held sessions on the train on the way to Seville. And then we had our big, celebratory luncheon event, etc., in Seville. So imagine how the world would change for our regions if you could actually split a conference like that up between Chicago, Bloomington, and St. Louis. You just can't do it today with cars or planes, but with high-speed rail you can. That's what we're working towards across the country in an integrated way. So our goal is to be the most knowledgeable independent source of information on what high-speed rail is, why we should build it, and what steps our state and federal leaders can make it happen. Our primary role is to educate folks all around the country about that through webinars like this. We're doing a lot of Rotary clubs. If you would like to set up a presentation for your Rotary club, we'd be happy to do that, and other means. And then the third is we give people the tools they need in order to educate their state leaders and their federal leaders. Our goal is a big federal program, one that can really make a difference in shifting from mode share from car to trains. In order to do that, we strongly believe that it needs to be 49 states at least. And just to be clear, that doesn't mean we're building new high-speed tracks everywhere, but it does mean that most major areas in all states have some improvement in passenger rail service. We need to think big, be optimistic, combining the transformative projects that take a while with quick near-term wins. And then we believe that a core problem is that challenge you hear a lot about, the stress between Amtrak and the freight railroads. We need to fix that by making passenger trains a good proposition for the privately owned railroads, just the same way that highway contractors make a very good living building government highways, and defense manufacturers make an extremely good living building weapons of mass destruction. So if you like what you see today, if you want high-speed rail in this country, please join us. We are supported by our members, and with your contribution, you are helping to educate folks and activate folks in key positions all around the country. And if you like, we'll send you a shirt if you go to our website, hsrail.org/shirts. So today I wanted, we've got Joshua Coran with Talgo here. He has been with Talgo for a very long time, and was going to talk about what makes Talgo unique and why it should be a key part of our integrated network. So Joshua, it's ready for you.
Thank you for that introduction, Rick. I'm really pleased to be here. Let me see if I can share the screen here. Do you see my screen?
Absolutely.
All right. Well, I think many people on the call may recall that you had a congressman from Massachusetts on one of these luncheons a couple months ago, Seth Moulton, who had proposed a $205 billion he put in a bill for that much money to build high-speed rail in the contiguous 48 states, maybe even including Alaska, I'm not sure. And in that presentation, he mentioned that he was getting his information about rolling stock from Siemens. And we thought perhaps he should know about another possibility there. So we put together a presentation for his staff and to introduce Talgo. And that's what this presentation started as. And you thought that perhaps people on this call would be interested in it. So it's organized a little bit strangely for that purpose, but I think it will be very educational for a lot of people. I'd like to go to the next slide, but it's not working. Oh, here we go. Okay. I'm not going to read this whole slide. It's basically tells you that Talgo has been around for a very long time, and it's a pretty substantial sized company. We're not anything like a Siemens or an Alstom, but we're not a small outfit either. That picture shows our latest and greatest, the Avril. It's our highest speed train, and you can tell just from the way it looks that it's every bit the equal of anybody else's high-speed equipment. Talgo is a Spanish acronym, so the noun first for train, articulated, lightweight, Goycochea Oreo. And Goycochea was the guy who came up with this little contraption you see in the small black and white picture. It was a proof of concept kind of thing that he built by himself. And the first actual serviceable equipment was actually built here in the United States in 1949. So we have a very long history in the US. This equipment demonstrated around the US for a while and resulted in, well, and then went to Spain. It was very successful in Spain. Success here in the US was a bit more limited, but there was some. ACF marketed the train sets heavily and sold one to the Rock Island. Did not sell a locomotive with it. That's a General Motors locomotive. Some of you may recognize it as being the one that the GM used for its equally unsuccessful train of tomorrow. They also sold two New England railroads, two related railroads at the time, Boston and Maine and New Haven. These also were not particularly successful, but there's a couple of interesting points about them. If you look at the black and white picture of the New Haven train, look at the back of the train, you'll see there's another locomotive back there. These were bi-directional, and that was very cutting edge at the time. And it may be an urban legend, but I heard that Ben Hyman of the Chicago Northwestern was inspired to solve his terminal problem in Chicago by inventing push-pull commuter trains because of this train. Who knows? It may actually be true. Over the years, we've come up with a variety of equipment. I'm going to talk mostly about the top right and the bottom two on the right. The rest are really just history at this point. And a bit of a diversion here. Talgo's success has been mostly in Spain and Eastern Europe. We do have equipment running in the Pacific Northwest. The Amtrak Cascade service between Eugene and Vancouver, BC, mostly between Portland and Seattle, has been protected by Amtrak equipment from the get-go in the late 90s. Our latest success has been in Saudi Arabia, where we were a member of the successful consortium that built a brand new railroad in very challenging conditions between Medina and Mecca. And we supplied the rolling stock. I think it's interesting to note that in the United States, we have a rule at, with government-funded contracts of 1% for the arts. In Saudi Arabia, apparently it's 3% for the king, because we built 35 train sets plus one more specially tricked out just for him. We often hear that the United States can't host successfully high-speed trains because it's too big. Well, China is about the same size as the United States, even almost same shape. Yet it has the most high-speed mileage of any country in the world. And I'll admit, I know China has much more people, and that means there are more people riding on the trains than would be a case in the United States. But the competitiveness with other modes is not a function of how many people are on the train. It's a function of the distance that they're traveling. And those distances are going to be similar. And even if you're talking about population density, we beat their average in a lot of places. And here are the 7 most populous or most highly populated, highest population density states. It's no surprise that all of them are on the Northeast Corridor. But of course, there are other areas of the country that are coming up like the Northeast Corridor. High-speed railroad is about to be built. Ground is about to be broken between Dallas and Houston. We all know about California, the Front Range around Denver, Atlanta. These places are coming into this kind of situation. But let's go back to this map of Spain and compare it to one of those regions, Chicago hub. These two are the same scale. You can see that the Madrid hub is very similar to the Chicago hub. And as Rick mentioned in his introduction, they're doing it in Spain. If they can do it there, we can do it between St. Louis and Chicago and Detroit and all these other places. So let's talk a little bit about what Talgo has to offer. This is our star of the fleet. It's the Talgo 350 is our major high-speed train. It is a standard gauge train, which is something I need to say because many on the call may not realize it, but the general system in Spain is Iberian gauge, which is almost 5'6". The high-speed lines, though, are all standard gauge, European standard gauge, which is exactly the same as ours, 1435 millimeters or 4'8.5". And so this train must run only on the high-speed lines, and it does so very successfully. And they're running, they're capable of 350 kilometers per hour, but they're running a little slower. 186 miles per hour is the proving to be the sweet spot. European trains are generally running at that speed. China, I think, has turned down the speed a little bit to that speed. Going faster saves very little additional time, and it creates some additional problems, especially with picking up ballast. But we also have, interior pictures of the train. It's really very elegant. The top pictures are of the business class, which is 3 across. But even in coach, which is 4 across, 2+2, you see this center armrest. In general, the seats face the center of each car. And at the center where the seats face each other, there's a table. And all the other seats, of course, have tray table type tables. To cope with this gauge situation, which is, of course, not a huge issue in the United States, fortunately, thanks to Abraham Lincoln, but it could be instructive here. We have the Talgo 250. It is a 250 kilometer train, so 155 miles an hour. It runs under both 3,000 volt DC overhead wire and 25,000 AC. It runs on Iberian gauge and standard gauge, and it makes the transition without stopping by running through a facility at about 10 miles an hour, which one after the other lifts the wheel, unlocks it, slides the two wheels closer together or farther apart and relocks them and sets them down on the new gauge track. That allows this train to run almost anywhere in Spain. And I say almost because the only place it can't run is where there's no overhead wire. And this is where it becomes appropriate for us. Here's a version of the Talgo 250. And you'll notice that behind the locomotive is another windowless vehicle. It's a power car. It's got a diesel generator set in it. And when you're running under the wire, as is shown here, of course, the pantograph is up and you're taking power from the overhead. when you're on a branch line without overhead wire, the pantograph comes down and a transfer switch connects the electric locomotive to that generator set, and you're off and running on the non-electrified line. Now, because of the limitation of the horsepower in that generator set, we're limited to, in this version, 112 miles an hour. I think we'd all be delighted to be limited to 112 miles an hour. And of course, with a lighter train or a bigger generator set, we could go a little faster. Latest and greatest is our Talgo Avril, which is even higher speed, 380 kilometers per hour, and it's wider, so it can offer 3+2 seating. We all know how popular center seats are on airplanes. I'm not really sure how popular this will be, but it does also allow very nice wide coach seating. This strange outfit is what we've offered in the US. It was developed about 10 years ago, well, more like 12 or 13 years ago now, based on the then current requirements, FRA requirements for operation on our general system here. And that's why it looks as weird as it does, partly because of the Spanish interpretation of those rules. Primary among them is the long-standing 800,000 pounds of buff on line of draft with no permanent deformation requirement. That rule originated from a post office rule in 1912 for wooden railway post office cars. It was, to put it mildly, out of date. Finally, I had been on the committee for over 10 years, working with the FRA to update these regulations. And finally, in November of 2018, the FRA published a final rule, which would allow alternate ways of producing a similar level of safety to that 800,000 pound buff rule. This equipment was built according to the old rule, but future equipment is going to be basically, the new rules basically allow European style crashworthiness to operate in this country. And future Talgo trains for the US will probably look a lot more like this one. But what's so great about Talgo? Well, we do have some unique features, and being unique doesn't get you anything unless there's some real advantage to it. So our uniqueness gives us several advantages. Our middle name, I tell people, is lightweight. That's what the L in Talgo stands for. And the lightweight, which is due to our aluminum construction, basically, gives us higher efficiency in terms of energy. And depending how that energy is generated, of course, that means less greenhouse gases in many cases as well. And if you believe that F equals ma, if the force stays the same as the mass goes down, the acceleration can go up. And that, of course, saves trip time. Probably that next bullet should have been the first one. These train sets are articulated, and in the case of a derailment, that has proven time and again to be a far safer design than separate cars. The lighter weight also reduces the wear and tear on the track. And anybody who's ridden the Northeast Corridor has probably noticed it's a pretty rough ride. And I suspect it's at least partially due to the very, very heavy Acela, which beats up that railroad at high speeds. The new Acela, the Acela replacement, is going to be built according to the new FRA rules. and will be much, much lighter than the current Acela, which will not only reduce maintenance on the track, it's going to reduce the maintenance on the train set itself as well. The last two bullets are related, and I'll get into that in a couple of minutes here, a couple of slides. We do have a trick for going around curves. The lightweight is, as I mentioned, it was aluminum construction. The car bodies are made out of full-length aluminum, double-walled aluminum extrusions. The Amtrak Horizon cars are built in a similar fashion. However, they're on a steel underframe. Our cars are entirely aluminum. And the articulated connections I mentioned provide a safer condition. They reduce drag. And they also provide a more hospitable environment when you're walking from one car to the other. In our present environment, I think we've all experienced this guillotining effect as you go into curves, and the footplate of one car rising up above another, which could be a tripping hazard, especially for elderly people who may be dragging their feet. This can't happen with this articulated connection. We get angles between the cars, but we don't get any offset between them. Our wheel sets are located between the cars, and each car is basically a semi-trailer. So what happens is each car has one wheel at one end and hangs on the next car at the other. And this goes down through the train, but of course, at some point, one car has to have four wheels. So everywhere on the train, there is a car with four wheels. In the older trains, it was our baggage cars on one end. In the current model, it's the food service car, what we call the bistro, which would be in the middle of the train, somewhere in the middle. This provides a method for steering, which is unique to Talgo at this point in North America. I don't know how many on the call know how trains steer. I won't go into great detail, but it's due to the fact that the wheels and the conventional equipment are pressed on a common axle. They turn at the same rate, and they have a tapered tread. And this tends to keep the wheel set centered in between the rails. Freight cars use a 1 in 20 taper. Passenger cars using the 1 in 20 taper tend to overcorrect at higher speeds, and they start bouncing back and forth. So most passenger cars use a 1 in 40 taper. The Acela uses basically a cylindrical wheel with a generous radius near the flange, and it has hunting detectors to slow the train if it starts bouncing back and forth. The Talgo system is completely different. Wheels are on a short shaft, each with their own bearings. They turn independently. We have between them nothing. I call it a virtual axle. And so they have to be steered in a different way. And we do it with these arms. And this next slide shows how they work. You see the arm coming from the car on the left over the top of the journal box is connected to this vertical lever. And the bottom of that lever is connected to the adjacent car to the right. So on the outside of a curve, the car bodies spread apart. The arms pull apart and the lever rotates to the counterclockwise. On the inside of the curve, the car bodies get closer together and the lever rotates clockwise. But in both cases, the wheel center stays midway between the two car bodies, and the virtual axle is on the radius of the curve. That means that the wheels are parallel to the rail. So there's no flanging. There's no flange climb derailment potential, and there's no hunting at any speed. This is the same system that was used by the turbo train, some people may remember. It was invented by an American back in the 1950s. I said that we have a trick about going around curves, and this little illustration makes it much easier to understand. I think we all recognize highways are banked to compensate for centrifugal force, and railways are too. We call it super elevation because the outside rail on the curve is elevated higher than the basic elevation of the inside rail. There's limitations as to how much we can raise that rail, though. The FRA limit is 7 inches. The practical limit has long been 6, but most railroads these days are limiting it to 5 inches. The reason is we have to be able to safely stop on the curve. And picture a high center of gravity freight car, like maybe a double stack, stopped on a curve with a 6-inch super elevation, and very close to tipping over. So this limits how much centrifugal force we can compensate. And the faster we go, of course, the more centrifugal force there is. So this amusement park ride shown on the left, it's obvious, I think everybody realizes the faster that ride goes, the harder it is for that poor guy to hold on to his seat. But the variation on the right, when it goes faster, those seats just swing out farther. And the guy sitting in them is pushed down into his seat a little bit harder, but he doesn't have any force pushing him to the left or right. He is kind of confused about what's happened to the level of the ground because it looks like it's tilted to him, but he's very comfortable in his seat. And our suspension system imitates that kind of a ride. The springs are up near the roof, and the center of gravity, of course, is lower. So when we go into a curve that it doesn't have enough super elevation, the car body swings out to compensate. And this is a picture of the train cut apart, and you can see how the springs are up near the top. The roll center is actually a little higher because the springs move sideways as well as up and down. And the center of gravity, of course, is much lower, and that gives us what we call a couple, which will cause the car body to tilt in the desired direction. And the result is that here in the Pacific Northwest, we have numerous curves where passenger trains, conventional trains, have to slow down to 65 miles an hour. Talgo is allowed 75 in this particular curve. And this arrangement has saved about 10 minutes between Seattle and Portland ever since we went into business in the 1990s. One criticism of Talgo equipment is that we can't switch out the car. We can't call the yard crew in 15 minutes, add the car to the train or take one out. But we do have a certain amount of flexibility. We can do that, by the way, in the shop. It does take 8 hours or so. And we can run trains in combination. So there's a certain amount of flexibility there. It's important to point out that more and more train concepts are becoming less and less flexible anyway. On Via Rail, they have no train sets. All of their equipment Via Rail is standalone cars. And yet they change concepts twice a year. They do it seasonally. And the reason is that once they get the concepts together working, they don't want to mess around with it, especially in their severe winter weather. And it's becoming more and more common that these trains are running as fixed consists. All new high-speed trains are articulated. And the airline model of pricing according to traffic demand is probably the way of the future here because of that. In the United States, we have 2 of these Talgo 8 FRA compliant train sets running in the Pacific Northwest, and enough equipment to make 2 or 3 more that is available because the good people in Wisconsin changed governments a few years ago, and the new Tea Party governor told us to take our trains and go home. So this is the bistro that is brand new, 10 years old, never run anywhere. And we have coaches that are very nice. You notice the center armrests there. Again, as I mentioned before, the seats face center, and so there's table at the center for 4 passengers, and everybody else has tray tables. This equipment was all built here in the United States. The car bodies were, the box was made in Spain because we have specialized welding equipment there, but all of the equipment was installed here in Milwaukee. This is a picture of a Milwaukee plant building the Wisconsin equipment. These cars have very low floor height, making it very easy to board from a low-level platform, just a couple of steps up. And if you don't have, you're not capable of making those 2 steps, maybe you're in a wheelchair or maybe you're not, maybe you just have a walker or you have a cane. Every 86 feet along the train, there's a wheelchair lift and you can get a ride up to the train. Once you're on board, no steps anywhere in this train and no mismatch in height, as I mentioned earlier. We do have a bit of a challenge in the Northeast in that our floor is well below the 48-inch platform height, but we're working on an innovation that will allow us to provide level boarding there. This picture was taken in Europe, where the platform height is equal to our floor height. We're the only manufacturer that has that feature. Talgo has a lot of innovation going on, and this particular one caught my attention. It's an app for your mobile device. If you're blind or deaf, you can get your train announcements on your own personal device. And because Talgo pioneered the articulation, and articulation created the maintenance issue that, if anything goes wrong on the train, anywhere on the train, you can't just take the car out, the whole train comes out. So it's pioneered also maintenance practices. And the latest and greatest is what is being called reliability-centered maintenance. So the goal is to bring the last bit of economic value out of each piece on the train and remove it and replace it, rebuild it, whatever it needs, just before it breaks. So we maintain our high level of reliability and availability, and also minimize cost. So that's the Talgo story, and I'm happy to answer any questions I might have created in telling it.
Sorry about that. If you can unshare, if you like. If there's any questions, I'd be happy to take them to get the process started. I think you answered this, but let's be sure. What is the fate of the 2 Wisconsin train sets?
Well, I tell people it depends on what's in your wallet. I can make you a deal right now. They are available 2 for the price of 1, or maybe even 3. There's enough equipment to actually build 3 smaller train sets. The equipment does not have a locomotive, but that funny looking cab car has a generator set in it for head-end power. So bring your own locomotive, and it can even be a freight locomotive. And we have the equipment that it can run with.
Excellent. So what's the advantage of having a locomotive with a cab car on one end versus having, why am I spacing out? A locomotive on one end, a cab car on the other end, or distributed power?
Yeah, distributed power is becoming common in Europe. I would say that our arrangement gives us an advantage in that the locomotives tend to be heavy. Well, anywhere you have traction tends to be heavy. And by concentrating at the ends of our train, it provides a margin of safety and allows the rest of the train to be very light. And I mentioned the F equals ma equation. By keeping the force, by having a sufficient weight on drivers, and steel wheel on steel rail tends to slip, but having enough weight on those wheels gives us equal force to anybody else's accelerating force, and the lighter weight results in higher acceleration.
So you're saying by concentrating everything in the locomotive, you actually end up with overall lighter trains?
Yeah, I think it does. In our case, it certainly does. And we are looking into powering some of our axles, but since they're virtual, we have to power each wheel separately. So that's a challenge, and the technology is coming. I think we may be able to do that.
Okay. A topic you brought up about not being able to pull out a car or put in a car at a moment's notice. A guy who was very experienced in this and spent a couple of days explaining how to market trains to the riders, and spent a good day explaining that the train set is the foundation for what you're marketing. Pointed out that it's very expensive to have a crew go out and change a train around. So maybe that's not a good idea because it costs money to do that. And then you've got the challenge of if maybe the maintenance crew gets lazy and just says, well, we'll pull that car out and fix it later. And then it sits on a siding someplace for days and days and days instead of just getting it fixed. So
I think that's absolutely the point I often make, that they say that if a car comes out because it's defective, you can put the spare in. Well, do you have a spare? Is it serviceable? The bean counters aren't really happy about having a bunch of spares. So keeping it running is the right way to do it.
Exactly, exactly. Um, so Barry is asking how often, so to clarify, in Europe, the standard length is 200 meters, and frequently you put together two for a 400-meter long train.
Mm.
Right? And so he's asking how often is it that the two train sets are together, and then are all the station platforms designed to be 400 meters long?
I suspect you have a better answer than I do. I do not know how often. And I'm sure that where they run such trains, they have sufficient length platforms, but how often it's done, I don't know.
Okay. And then, so you kind of hit on this, but part of your philosophy is keeping the trains maintained very well. So you've got an incredibly good availability rate. And again, the bean counters don't like spares. They like having the assets being used all the time.
Yeah.
What role does the person, do you still have employees riding each train, and what role do they play in that?
We are doing away with them company-wide because they're being replaced by the electronics. The trains are, the function of the guy on the onboard tech, as we called him, he had two functions. He did a certain amount of preventive maintenance and some PR work too, I guess, on board while the train was running. And he also reported back to maintenance any issues that he couldn't fix. The trains are now reporting back to maintenance on their own. We have this communication system set up. So the onboard techs are becoming less and less necessary. We still use them occasionally, but not on every train.
Okay. A painful question that I think I know the answer to. The trains from the 90s got shipped to a scrap yard. Have they been scrapped, or is anybody?
The Washington owned two are in the process of being scrapped. I think one has been, the other is not yet. The two that were owned by Amtrak are stored at Beech Grove. Fate unknown.
Okay, so we need to be very clear. Those were a different design than the ones that were built in 2009.
Yeah.
And the 2009s are still running.
Yes, they are. The older ones were built to UIC, European standards, were running under a grandfathering provision on the FRA because they didn't have the 800,000 pounds of buff and line of draft requirement. They didn't meet that requirement. It turns out they do meet the requirements of the new final rule, the one I mentioned that was published in the end of 19, became effective in end of 18, became effective in January of 2019.
So that's very disappointing. How does the maintenance work? Is it your own employees, or is it the railroad's employees?
Here in Seattle, it's the railroad's employees because it's a Seattle, the Amtrak facility. Of course, it's a unionized facility. So we supervise and they provide the hourly labor.
Okay. And what's the width of a Talgo versus like an Amfleet or a Horizon?
They're a little narrower to allow the pendulation tilting, 108 inches as opposed to 120 or 126 at the belt rail of the curved sided cars.
Okay.
The Avrail, by the way, is a little bit wider, but I don't offhand know how much wider it is.
Okay. And then Beth is pointing out that often you could run more frequent trains instead of doubling them up.
Obviously, is a much more preferable choice for the passenger. But here we were sharing space with freight railroads. Sometimes we're limited to how many slots we get.
Exactly. Um, I will ask this question exactly as is. What other North American routes is Talgo looking at for marketing?
Well, any of them that are presently in play. Talk to just about everybody you can think of. And we've talked a lot to the Southern Rail Commission, I think, is interested in our equipment right now.
Excellent. And then something that, so we've got this challenge where the first high-speed line under construction is hopefully the legislature will move forward with the authority's business plan and build it from Merced to Bakersfield. And for those of you who are interested more in California, we have a more in-depth presentation on that a week from today. But right now they're designing it for a cross-platform transfer at Merced, which I believe will be very effective. And they're actually designing the station so that you'll just walk from one train to another. And I've done that in multiple places around the world. But for marketing purposes and for other reasons, it would actually be much more desirable to just have those trains go through. But you've got the challenge of two, one, the biggest being the electrification, and the other being you need very rigid trucks. The faster you go, the more rigid you need to be on the suspension. So how could Talgo be part of the solution to that challenge? And we've got that all around the country.
Well, we have the solution in the middle of our train. There's no problem whatsoever. Share that same problem with everybody else in the motor truck, the locomotives truck where we have the traction motors. And it is a major problem. We have there's a legacy in this country that came from our staggered joint practice. In Europe, the joints, back when we had jointed rail, the joints were square, they were across from each other. Here they were staggered, so every other half rail length. And as a result, we would have what we call short warp occasionally. We'd have the rails doing this kind of thing. And so we require a very flexible truck, something that can equalize, it goes way, way back. When they brought the John Bull over from England, it worked fine in England and wouldn't stay on our track here. They had to invent equalization. And you can see it in the Smithsonian Museum to this day. I don't know how we're going to beat, and of course, we don't have jointed rail anymore, but we still have places where that kind of short warp is set in concrete, literally in Penn Station, New York, for example. So until we can get out of that and get all that old legacy infrastructure straightened out, it's going to be a problem for everybody.
Okay, so that's a much better explanation than I've heard before. I really appreciate that. I want to point out to the audience that having the joints together results in better ride quality, but requires more maintenance. And our railroad philosophy here is maintain it as little as you need to maintain it, and let's just run the trains, which is a challenge for running high quality freight trains and passenger trains. And then how do you think with having that booster, let's call it, behind the locomotive, would that help in terms of the electrification issue in this country?
Well, it greatly reduces the need for electrification. I'm not sure people would be too happy about having a diesel engine running back there, but technology is evolving, and it could be full of batteries that charge while the train is on the electrified portion. It could have a hydrogen fuel cell. Talgo is working on a fuel cell train set right
now. And then have you done analysis of any routes where, like Chicago to Detroit, how much time you could take off with a train set like this?
Yeah, of course, it depends on the amount of curvature on the railroad. And we did an analysis of Los Angeles to San Luis Obispo. And it was pretty dramatic. I think it was about 15 minutes of savings with no infrastructure improvements, which to save that much time by improving infrastructure on the coastline would cost $1 million, probably $1 billion.
Yeah. You know, the target for the Acela between New York and Boston was 3 hours, and I don't think they've met that. I think it's 3:15 right now.
I should have pointed out the Acela, I think everybody knows the Acela tilts, so does Talgo, but they use a totally different system. The Acela and the Canadian LRC originally as built have active systems. So they have pumps and sensors and rams and all kinds of claptrap. And the Canadians gave up on it years ago. They took all that stuff off. The LRCs do not tilt anymore. But with the Talgo equipment, it's just by the nature of the geometry.
Yeah. And then I was frustrated to learn that they did a test run without making any infrastructure improvements with a UA turbo train on Boston to New York. And they demonstrated that that train alone would make it a less than 3-hour trip without the electrification.
I rode that train from Boston to New York on several occasions. I don't remember now how much time it took. I probably have some notes.
Well, I'm not going to say the New Haven ran it well, or Amtrak.
The New Haven did a very good job for what it
had. Absolutely. Yuri thank you very much. The median time between New York and Boston for the Acela is 3:40, 3 hours and 40 minutes. Do you have any knowledge about what the environmental and safety issues around hydrogen fuel cells are?
I don't think I don't see an environmental issue because the product of combustion is water. There is a great deal of safety concerns because of the carrying of hydrogen. Everybody's picturing the Hindenburg. But I don't think I think it can be done safely. The big problem though is space required. The energy density of the hydrogen is nowhere near that of diesel fuel.
Okay. And that's true with batteries as well.
Oh yeah.
You know, there's a reason why we have gasoline and diesel powered vehicles. What's the status of your facility in Milwaukee?
We presently have some rebuild work. We're working for LA Metro and Metrolink, rebuilding Bombardier and I forgot the manufacturer now, some red line subway cars and Metrolink, so-called bi-level, the 3-level bi-level type commuter cars. So we're keeping the people busy there. I should have pointed out when I showed that slide that that was an old A.O. Smith facility that during World War II employed 10,000 people. And when we moved in, except for the night watchman, we were the only people there. So we brought 100 nice paying jobs to northwestern corner of Milwaukee.
Excellent. Let's see. So here's a tough question, but it might be on many people's minds. So the state of Washington, how do we, okay, let's just, so the crash with the Talgo train where the guy went around the turn too fast, there is a member asking, do you think a conventional train would have, how differently would have a conventional train have performed in that accident?
It's really hard to say. Every accident is different. But we've had, well, maybe I can draw a parallel. There was a conventional train that went around the curve at about the same 30-mile-an-hour curve at the same speed that we went around. And that was in the Bronx, New York on Metro North. And I think there were 8 people killed in that one. And the train came apart. It didn't hit anything. Whereas in our case, we hit the end of a bridge. It just went off into a flat area, but there were more people killed in that accident than in ours. So I think it's clear that the train performed very well. Everything actually was going according to plan. Everything was following the locomotive through the woods until the train had slowed down enough that one wheel set did stay on the track. That turned one car sideways and it hit the end of the bridge going sideways. That's what the 3 fatalities
were. Okay. And then with the AM fleets, it's clear after the Philadelphia accident that those need to be replaced as soon as possible.
And Amtrak announced that Siemens got the job last week, or I think earlier this week.
Yeah, absolutely. And then Beth is asking what the range is for the what is branded as Alvia trains are, the ones that can go on both electric and diesel sections. Do you know what the mile range?
I don't know. That relates to their fuel tank capacity, which I think is probably adjustable depending on their desired range. I don't think it's a limiting factor, but I don't know what it is.
Okay. Oh, there's more down here that I haven't seen.
It occurs to me while you're looking at it, I answered one question incorrectly. I don't know why I said 108. The width of the conventional Talgo is 115.
Okay. And you answered Fred's question about bidding on future equipment purchases. Yes, you are being aggressive about that. I'll leave this last, well, we don't know. If there are any more questions, speak now or forever hold your peace if you have any questions. Okay. And the answer to the anonymous is that it hasn't been announced yet what planes will replace the old Talgos, what kinds of trains will replace the old Talgos. Excellent. We've got a comment here from one of our board members, Beth Colson. I love Talgo Trains. So,
thank you.
Well, thank you very much for joining us. I really appreciate this. Phil, Phil, I haven't used the can you talk. I'm going to allow you to talk, Phil, and let's see how this works. Mr. Darling, are you there? Okay, so it doesn't work. Well, thank you very much for changing back to attendee. Thank you very much, Joshua, for being with us today. This was a very informative presentation. I really appreciate your time. For the folks who have joined us, we are in the process right now of ramping up our communications work. We've got exciting opportunities happening in the Midwest, in California, and at the national level, and we really need to up that. So if you liked this presentation, if you want to see more of it, and if you want to have a role in getting the word out to a lot more people, please go to our site, hsrail.org, and make a donation. And we appreciate you for coming. And Josh, again, thank you for being here today.